Hello, dear student. How are you? I hope you are all will be fine. I'm also fine. Thank you. Let's start today topic. Today is lecture number 14 of nucleophilic substitution reaction. And today lecture we will be studying about SNI reaction. In previous lectures we already studied about SN1 reaction and SN2 reaction, in comparison between SN1 reaction and SN2 reaction, as well as we explained with very detail in many lecture SN1 as well as SN2 reaction, SN2 mechanism. So now today lecture we will be studying SNI mechanism. SNI mechanism. What is meant by SNI mechanism? SNI, it stands for, I stand for internal, N stand for nucleophilic, S stand for substitution. So SNI stand for substitution nucleophilic internally. Substitution nucleophilic internal internally. What this mean? It means that nucleophile will be internal nucleophile will be used in this substitution reaction. In SN2 reaction, external nucleophile used. External nucleophile means two different nucleophile, two different reactants. One is nucleophile and one is substrate. It will be used. Here is nucleophile and substrate are belong from the same molecule, like this. This is the one compound. Like this is the compound. Here in this case this oxygen is electronegative oxygen, so that's why it's withdraw electron from this carbon. That's why this carbon get partial positive charge and will be act as an electrophile. The marker is not properly working. Let's change the marker. Here this oxygen is electronegative oxygen and it withdraw electron from this carbon, from this bond. Due to this polarization, the bond that become polarized, the carbon will get partial positive charge. So that's why here this carbon will be act as an electrophile, and within the molecule this Cl will be act as a nucleophile. This Cl will be act as a nucleophile, and with this bond will be shift towards this carbon and it will be attack on this carbon. So that's why internally a nucleophile will be used internally. Substitution will be occur. It will be like this. CH3, it will generate this product plus SO2. This is the internal substitution reaction. I hope it will be cleared. Here in this case, substitution is internally occur. Substitution will be internally occur. Substitution of nucleophile will be internally occurred. In this case, in this reaction, SNI stands for substitution nucleophilic internal. Also, SNI reaction, internal substitution reaction, it is also two-step mechanism. Its mechanism will be two-step mechanism. Its mechanism will be two-step mechanism. Here it will be two-step mechanism. In first step, intimate ion pair will be produced. In first step, intimate ion pair will be produced. Intimate ion pair will be produced. What is meant by intimate pair? Intimate ion pair will be produced. While in second step, the final product will be produced. Final product, final substitution will be occur. Final substitution will be occur. I will be clear this point, intimate ion pair, later. Also, internal reaction or SNI reaction, it follows second order reaction. It follows second order reaction. Second order reaction. It follows second order reaction. And the rate of the reaction will be will be Let's suppose take some example. After that I will calculate its rate. One example is when phenyl attach with carbon and methyl also. Here in this case when OH is initially required, initially attached, and OH will be replaced in the presence of SOCl2. In the presence of SOCl2, it will produce the final product plus Cl plus SO2 plus H2O. It will generate this product, not H2O, that is HCl. Yeah, it will generate this product. So for this reaction, the rate of the reaction will be Kn2. It will directly depend upon pH, HCME, OH, this this one. After that, S will also depend upon SOCl2. So the rate of the reaction will be like that. That will be second order reaction. The order of this is 1, the order of this is 1. So the total order will be second order. The net result will be second order reaction. And also mostly the product of the SNI, the product of SNI will be retention product. It will be retention product mostly, in most cases. Here is also retention because from where the hydroxyl ion or leaving group left the system, the coming group or the nucleophile will be attacked from the same sides. So that's why the final product will be, this product will be retention product to the original one in most cases. But there is some cases where also product will be inversion can take place. Let's do mechanism for the reaction. Mechanism for the same reaction, for the given reaction. The mechanism will be this. The step number 1. In step 1, phenyl CHMeOH. In step number 1, plus from the product SO, from the solvent S double bond O, Cl. Yeah, this oxygen, the lone pair of this oxygen will be attacked on this chlorine and on this sulfur. So that's why this bond will be shift toward this hydrogen. And the bond between hydroxyl ion, the bond between hydrogen and oxygen will be break down. So, and the product will be generate intimate pair ion. That is O negative. Here is O become negative. Not O negative. Here is carbon become negative. Or you can say that here it will be like this. That is O that bonded with sulfur, double bond O, Cl plus HCl generate. This is the product. This is one product, that is HCl. So this will be, we can write this in the form of intimate pair ion. It can be write as like that. That is methyl. This has plus ion. This has plus charge plus OSOCl. This oxygen has negative charge. So these are the compound. These are the salt that is called intimate ion pair. These two are the intimate pair. Here the chlorine will be shift toward this carbon. After that, and this the oxygen that are bonded with this carbon, it will be shift toward this. So it produce SO2 sulfuric acid, and as well as it produce the final product. How it will be generate? The second step it will be like that. In step number 2 it will be like this. This is the intimate pair ion. The intimate pair ion, that is phenyl CHMe. This is plus O S double bond OCl negative. So it will directly generate, and this will due to loss of SO2 negative ion, so it will generate PHCHMeCl. This is the final product plus SO2. This is final product are in the presence of covalent mechanism. Like in this is the covalent mechanism process. In this it will be in the form of covalent mechanism process. Covalent mechanism, it will be, the mechanism will be like that. This is the phenyl that attach with carbon H, this, and methyl O S double bond O Cl. This is Cl. So here in this case, due to this oxygen, this is electronegative oxygen, so it withdraw the electron from this bond. That's why the carbon become polarized and the carbon become electron deficient. So that's why it will be act as electrophile, and this bond, the bond between sulfur and chlorine, it will be attack on this carbon. It is the electronegative element, so that's why it will be attack on this electrophilic carbon. So due to this this bond, the bond between oxygen and carbon, it will be shift toward here and produce SO2 ion. So it will produce the final product HMeCl plus SO2. This is the final products. I hope the SNI mechanism will be cleared. This is the general mechanism of SNI reaction: substitution, internal nucleophilic substitution reaction. This is the general mechanism and general characteristic of substitution reaction, SNI reaction. Here one of the property is sometime rearrangement will also be needed. Rearrangement will also be occur, will be required. Sometimes rearrangement will be required due to produce the most stable carbocation. To produce, due to the stability of the carbocation, rearrangement will be occurred. How? Let's do one example on this. I am cleaning the board because it become, you can also take screenshot or you can rewind the video. Okay, let's take one example. CH3C, CH3C, CH3. Here is also H attached. H C H, that is OH. In the presence of this, when you add SOCl2, sorry, not Cl3, and it reduce HCl, and so that's why it will be produced, or you can say that it will directly, this will be produced, this product CH3. This will be generate this product Cl CH2 CH3. It will be generate this product. This is this, but this is the product. This is the product of rearrangement. This is the product that are rearranged, that is formed due to the rearrangement. But the normal product, normal product will be like this: CH3C, CH3, H, CH2, CH3, not H2, here is only H, and Cl. This is the normal product. This is the normal product. This is the expected product. While the observed product or the rare product will be like this. This will be, or the original product will be here as this. This product is produced due to the rearrangement. How? Let's do mechanism of this reaction. In step number 1, mechanism, in mechanism in step number 1, CH3 CH CH3 CH CH3. In step number 1, it will be like this one. This is the SCl double bond O Cl. This oxygen, this lone pair will be attack on this sulfur. Due to this, chlorine bond will be shift toward this hydrogen, and it will produce stable compound, but not in a stable. CH CH CH3, that is O, it here is sulfur double bond OCl plus HCl. Yeah, if you write this in the form of, antimat ion pair, it will be like this one. CH3 CH CH3 CH CH3 plus charge O negative sulfur double bond OCl. Yeah, here is, this is the carbocation, but this is the secondary carbocation, because one alkyl group, second alkyl group, so this is the secondary carbocation, and we know that the secondary carbocation is not enough stable like the tertiary carbocation. Tertiary carbocation is very stable, so that's why here is rearrangement will be occur, and due to hydride shift, here hydride shift will be generated. It is the symbol of hydride shift. So due to the hydride shift, it will be like this. CH3, this hydrogen will be shift toward this carbon. This hydrogen will be shift toward this carbon. CH3 CH2, here is one hydrogen, also the another hydrogen will be shift toward here. When this hydrogen shift toward this carbon, so that's why this carbon will be get positive charge. This is positive charge, CH2 and CH3. Now this carbocation is secondary tertiary carbocation. This is tertiary carbocation, OS double bond OCl. But here, when you write this in the form of covalent mechanism, it will be like this one. So here, this chlorine will be attack on this electrophilic carbon. This is the electrophilic carbon, because this is bonded with the electronegative elements, and this electronegative element withdraw the electron from this carbon. Due to this carbon due to this withdrawing of oxygen electron, this carbon will be get partial positive charge and become more electropositive and become positive, so that's why it will be get act as a electrophile. So here this chlorine will be attack on as a nucleophile, internal nucleophile. It will be attack on this carbon, and this bond will be shift toward here, and the final product will be generated. While this is also the step 2, this is also step 2, and the final product will be generated. CH3C CH3 CH2 CH3, that is Cl. It will be like this. This is the final product. Now I hope also you can say that this is the rearranged product. This is the rearranged product. It is due to the 1,2 hydride shift, because from the one carbon, from the first carbon, this was the first carbon, because it is attached with the hydroxyl group. So this is the first carbon, second carbon, third, fourth. So 1,2 hydride shift occur. 1,2 hydride shift from the second carbon hydride shift towards the first carbon, due to getting stable carbocation. I hope SNI mechanism or internal nucleophilic substitution reaction will be clear. If you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in description box. You can get from there. Okay, please also subscribe my channel. It makes me feel happy that my students are supporting me. Okay, thank you very much. Very best of luck, my dear student. Very best of luck.